The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
The James Webb Space Telescope is shaking up everything we thought we knew. Suddenly, it feels like we might need to rewrite the textbooks about the very beginning of the universe. When Webb turned its ultra-sensitive eyes toward Pluto, nobody expected what it would reveal. The images that came back weren't just clearer, they were revolutionary. For decades, Pluto has been a distant mystery shrouded in icy darkness. Even after NASA's New Horizons flyby in 2015, we were left with more questions than answers. But now, with Webb's powerful infrared capabilities and unmatched resolution, we're seeing Pluto like never before. The implications of this data are staggering. Pluto, once known as the 9th planet of our solar system, continues to fascinate scientists and space enthusiasts alike. Situated in the Kuiper Belt, over 3.66 billion miles from Earth, this dwarf planet has always been difficult to study in detail. Traditional telescopes, even Hubble, could only provide blurry glimpses of its surface. But Webb has completely changed the game. With its 6.5-meter gold-coated mirror and position beyond Earth's atmosphere, Webb captures light from distant objects with unprecedented precision. When it focused on Pluto, the resulting images revealed textures, surface features, and atmospheric details that had never been seen before. What makes this so remarkable is how Webb operates. Unlike visible light telescopes, it observes the universe primarily in infrared wavelengths. This allows it to detect heat signatures and subtle variations in temperature and composition that optical telescopes simply can't see. For Pluto, this means scientists can peer through its thin atmosphere and detect changes in surface ice and even potential geological activity. The new images released by NASA and the European Space Agency reveal intricate details of Pluto's nitrogen ice plains, towering mountains, and possibly even seasonal changes in its atmosphere. One of the most stunning discoveries is the sheer detail of Sputnik Planitia, the heart-shaped region on Pluto's surface. This icy plain, mostly nitrogen, was first captured by New Horizons, but Webb's infrared sensitivity shows depth and texture that were previously invisible. Variations in brightness suggest ongoing surface processes, possibly sublimation or deposition of ice, indicating that Pluto may still be geologically active despite its small size and frigid environment. Webb's data also allows scientists to study Pluto's thin atmosphere in ways never possible before. Composed mostly of nitrogen, with traces of methane and carbon monoxide, Pluto's atmosphere is cold and tenuous. But in the infrared, subtle shifts in temperature and composition become visible. Researchers can now track changes in atmospheric pressure and temperature over time, offering clues about Pluto's seasonal cycles, which span its 248-year orbit around the Sun. And it's not just Pluto itself. Webb has also captured new details about its 5 known moons, especially Charon, the largest and closest. Charon has long intrigued scientists because it's half the diameter of Pluto and always shows the same face toward it. Webb's imaging reveals fresh insights into Charon's surface composition, showing possible frozen ammonia, complex hydrocarbons, and crust changes that could suggest a more dynamic geological history than we realized. Beyond Charon, Webb has observed Pluto's smaller moons, Styx, Nix, Kerberos, and Hydra, providing unprecedented views and data that will help scientists understand the full complexity of this distant system. These tiny, irregularly shaped moons have long been difficult to study because of their small size and vast distance. But with Webb, scientists can now refine their orbits, estimate surface compositions, and gain a clearer picture of their origins. This is helping us understand the Pluto system as a whole and the dynamic processes happening in the outer solar system. Even more fascinating is how these images reignite the debate about Pluto's planetary status. Although the International Astronomical Union reclassified Pluto as a dwarf planet in 2006, Webb's new data highlights its complexity and active geology, challenging the reasons behind that demotion. Many astronomers now argue that Pluto displays traits more typical of full-fledged planets, including layered geology, an atmosphere, and even potential subsurface oceans. These high-resolution observations also underscore the importance of continuing to explore the Kuiper Belt. Pluto is just one of thousands of icy bodies orbiting the Sun beyond Neptune. With Webb's clarity, researchers can now target other objects more accurately, including dwarf planets like Eris, Makemake, and Haumea, as well as mysterious worlds still waiting to be discovered. Each new image adds another piece to the puzzle of how our solar system formed and evolved over billions of years. The James Webb Space Telescope is more than just a new set of eyes in space. It represents a leap in how we observe and understand the universe. Unlike Hubble, which mainly focused on optical and ultraviolet wavelengths, Webb's infrared capabilities allow it to see through dust, detect faint heat sources, and reveal objects that were too cold or distant to detect before. This is especially important for studying icy worlds like Pluto, which emit very little visible light but glow in the infrared. Webb's success in imaging Pluto also pushes the boundaries of what space telescopes can achieve. Capturing such detail required Webb's fine guidance sensors to operate with extreme precision, compensating for both the spacecraft's movement and Pluto's slow drift against the stars. This highlights Webb's versatility. It can peer billions of years into the past to study ancient galaxies, and it can also deliver crisp, detailed data from objects in our own solar system. This unique capability opens the door to studying other distant worlds, like Triton, Neptune's mysterious moon, or Eris, another large Kuiper Belt object. With every observation, Webb expands our understanding of the solar system's farthest reaches, a region still largely unexplored and full of potential discoveries. As scientists continue to analyze Webb's Pluto data, new questions are emerging. Could there be a hidden subsurface ocean beneath Pluto's icy shell, similar to moons like Europa or Enceladus? What drives the apparent geological activity on such a distant and frigid world? Are cryovolcanoes reshaping the surface, releasing volatile compounds from Pluto's interior? Webb can't answer all these questions, but it helps frame them clearly, providing crucial clues for the next generation of missions and theories. Another exciting outcome of Webb's detailed imaging is the opportunity for comparative planetology. By studying Pluto alongside other icy worlds, scientists can identify patterns and differences that reveal broader processes shaping the outer solar system. For example, how does Pluto's nitrogen cycle compare to that of Triton? Are the organic compounds found on Pluto similar to those on Titan? Is there evidence in Pluto's crust of ancient collisions or a chaotic early history in the Kuiper Belt? These comparisons don't just teach us about our own solar system, they deepen our understanding of planetary evolution in the exoplanet systems Webb is designed to explore. Yet perhaps the most profound impact of this new image isn't just in the scientific data, it's what it represents for humanity. Only a few decades ago, Pluto was a blurry, featureless, even in the best telescopes. It was distant, mysterious, and largely unknowable. Now, thanks to the James Webb Space Telescope, we can see Pluto's icy plains, rugged mountains, and delicate atmosphere in astonishing detail. We can trace patterns in its frozen heart and witness the slow dance of its moons. We can begin to tell its story. This isn't just progress in planetary science. It's a testament to human curiosity and determination. Every breakthrough image, every new piece of data, is the result of decades of work by scientists, engineers, astronomers, and dreamers, all pushing beyond what once seemed possible. Webb's image of Pluto reminds us that the universe is always ready to reveal something new, if we have the tools and the will to look. So as we gaze at this crystal-clear picture of Pluto, we're reminded of the journey, from its discovery in 1930 to the flyby of new horizons, and now this next chapter with Webb. It's a story of exploration, innovation, and the unending quest to understand the cosmos. And it's far from over. With every observation, Webb is not just capturing light from across the universe, it's illuminating the path forward. The James Webb Space Telescope's image of Pluto marks a new era in our understanding of the outer solar system. It's not just a picture. It's a revelation. A glimpse into a world once thought too distant to ever truly know, now brought vividly into focus. And it's a promise that as long as we keep reaching, the universe will keep answering.